We want to find the first and second derivative of this. Quite straightforward. What rule should we use? Product rule. So u is square root of x, the ln of x. What is the first thing that we're supposed to do here? Find the derivative. That is true. But
Of those.
Yeah.
Oh, it's like it's 1/2 square root of x.
that is the answer. Good job, Peter. So 1/2 x raised minus 1/2. By now you should know what the derivative of square root of x is. It is simply 1/2 square root of x. What is the derivative of ln of x? 1/x. So y prime u v prime plus v u prime and you may say, I'll just keep it as is and proceed with finding the derivative. Sure, you can, but x, you can write it as x raised 1/2 times x raised 1/2. Bases are identical, add the powers, you get x. And over there, I simply have 1 square root of x, 2 square root of x multiplied by ln of x. What happens to this term and that term will get cancelled. I can rewrite x raised 1/2 in terms of a radical. What is that radical? Square root of x. Good. What do we have in common? Square root of x. I can take the common denominator and then take 2 square root of x outside. Good. What is the common denominator now?
2 times the square root of x.
2 square root of x. Good so far. We want to find the derivative of that expression. How do we find the derivative? There are 2 ways to do it. What? We can either use product rule or quotient rule, correct? That would be u, that would be v. So to find the second derivative, I'm going to use quotient rule. 2 plus ln of x will be the numerator. The denominator is square root of x because I'm trying to keep that 2 outside. Why carry an additional term if there is no need for us to do that? What is u prime? V prime. Yes. Y double prime will then equal V U prime minus U V prime divided by V squared. Yes.
You could have picked either or, right?
Yeah, but if you had to use product rule, you must convert this to x raised 1/2 and move that to the numerator, then use product rule. I think quotient is easier in this case. Same process as the first derivative right here. I had x raised 1/2, x there, I cancelled it out, wrote it as 1 over square root of x. Going to do the same thing. Good. Divide by, what is the square root of x squared? Square root of x and then square. Should we stop right here or should we try to simplify? What does your mind tell you?
No,
No. I think we should simplify because there is a 2 here, probably a 2 is going to pop up there. I see a -2 there. It might get cancelled. I don't know, but perhaps it is going to. We'll see. Multiply and divide by 2.
You never did anything with the 1/2.
I'll throw that in at the very end. So I'm saving it for the very last step. So let's put a star so that I don't forget. That star is for that 1/2. It's going to come into place. Good so far? Yes, James.
Real quick, back at V and V prime, why is V just the square root of x, not 2 square root of x?
I kept that 2 outside.
Okay.
So you see, I put a star up there. We're going to multiply the very last step by 1/2. You could keep it as 2 square root of x. It's a matter of choice. So I have a common denominator in the numerator, so I can combine those two. Star is for that 1/2. What happens to the 2 and the -2? Get cancelled. So y double prime would be equal to the 1/2 that's out in the front. Is there a way to rewrite that? How? Right, just multiply the x and that term. Square root of x multiplied by x, what do we get? X. So this is x raised 1/2. Multiply that by x. What is it? I had it.
3/2.
3/2. Multiply the 2 and the 2. You can leave that as is, as x raised 3/2, or in terms of a radical, it is square root of x cubed.
Wait, where did you get 1/4?
2 times 2.
Oh,
Can you go over again how you got x3 squared?
Come again?
The x3 halves, how'd you get that?
If you flip and multiply, you'd have x multiplied by square root of x.
Okay.
So that will give you
Oh.
x raised 3.
but then wait, why did you multiply the 2's together? Oh, never mind.
Okay. I'll start with the inside expression. I want that to be bigger than 0. Yes, which means positive. I could also have equal to 0. Do you agree? Nothing wrong with that. Square root of 0 is 0. Move that 2 to the other side. Becomes -2. How do we solve for x? What? Exponentiate on both sides. We are at Gianna's favorite step. What are we going to do? This quickly. So x greater than or equal to e raised to -2. Of course, if you go back to algebra, the domain of natural logarithm is 1 all the way up to infinity. But we're being very specific. So for what values of x would that be positive or equal to 0? Those values. So the smallest value of x that we can use is e raised -2. What is the largest value? So we have the domain written for f. We want to find the derivative. Before I even start, we did this in the previous problem. If f of x is square root of x, what is the derivative of that? So it's 1/2 square root of x.
I know I got it right, but.
So 1/2 square root of x. So if I treat that entire expression as x, what is the derivative of that? It would simply be 1/2. That entire expression. Is that it?
No.
No. What is the derivative of 2?
Zero.
Oh,
Zero.
0. What is the derivative of ln of x? 1 over x. So 2 times x. One over 2x multiplied by square root of 2 plus ln of x. Do we agree? Now going on to the domain. Clearly we want this term to be greater than e raised negative 2. Yes. X cannot be 0 because it becomes undefined. That number definitely is bigger than 0. So x will only exist from 0 to infinity. This part will exist for e raised negative 2 up to infinity. Yes? That part 0 to infinity, that part e raised negative 2 to infinity. We've got to find the overlapping part. What is the overlapping part? If you can't see it directly, you could always draw zero to infinity for x, e raised negative 2 probably somewhere here. So what is the overlapping part? E raised negative 2 all the way up to infinity. We can't include e raised negative 2.
So that's what that would be the answer.
Yes, that's the domain of f prime of x.
Wait, what's the number?
With the closed bracket. With the closed.
Yeah, with the close bracket. Because I can still plug in. Sorry,
Zero.
without the close bracket, because you'll get 0 in the denominator. So
Just erase that.
the domain is actually e raised negative 2 up to infinity, not including e raised negative 2. Thank you for this. Because if I plug in e raised negative 2 in the denominator, that will become 0. So that's the domain for f prime of x.
Why did we multiply by 1 over x? That's
Let's change.
okay.
What do you mean?
I just didn't know where we got 1 over x from.
You don't
Other than
know, or
chain
you-
rule.
yeah.
So, yeah, it made sense out there.
So we've got to start from the outside function. That number, whatever value you get, that has to exist, right? If this number doesn't exist, that's not going to work. So we want to make sure that whatever we have inside has to be strictly bigger than 0. Do you agree? In algebra, we always wrote the domain for logarithm as 1 to infinity. In a sense, we restricted it, but if you graph natural logarithm of x, the curve would look like that. So 0, 1. We can get closer and closer to 0, but it just can't be 0. So the domain of natural logarithm is 0 up to infinity, not including 0. So whatever term that I have inside must be bigger than 0. Do you agree? Okay, how do we solve for x?
To take the e,
Exponentiate on both sides.
oh, 2 times.
What happens to the E and the ln?
That's the one.
Right hand side, it simply becomes
One.
1. On this side, we have ln of x. What should we do now? Exponentiate again. Good. The E and the ln would go away. So the value of x must be strictly greater than E. We cannot include E because if I included E, that would become 1, that would become 0. You would end up evaluating ln of 0, which is not doable. So the domain is from E all the way up to infinity, not including E. The key to getting the domain correct is to watch out for the exact inequality. And oftentimes you want to make sure that the value of the function is bigger than 0 or bigger than or equal to 0. Once you have that, it's just algebra to get to the value of x. Good. Well, that sort of is the tricky part. I want you to find the derivative. So the problem looks scary, but in fact, this is a very easy problem. All you have to do is focus and do the steps properly. So keep in mind you want to start with the alpha function and work your way in. So if I call whatever that is inside as x, what is the derivative of ln of, say, u?
1 over.
1 over whatever I have there. Yes, but then I realized that's not just x, rather it is a function of x. So I want to take the derivative of that. But this is a function within a function. So if I treat that as just x, what is the derivative of ln of that? 1 over ln of x. But then I realize it's not just x, rather it's ln of x. So what is the derivative of that? Good. Let's find the second derivative. Let's not, because it will be very complicated. So the answer is x, ln of x. Ln of x. Good. Here comes the most important, one of the most important reasons of logarithmic differentiation. Let's say we have f of x equals x squared plus 2 raised 4 times x squared plus 4 raised 8. Things like these do happen in mathematics. But how would you want to do this problem? Product rule, how? Product followed by change, right? So this is method 1.
Oh, method 1.
What's the number?
8. So I could call u to be x squared plus 2 raised 4. V x squared plus 4 raised 8. What is u prime?
Whatever the chain rule. Something.
It'd be 4. 4 squared plus 2 raised
Yeah.
to 5.
Are we done yet?
No, lines through.
Yes. Same over here. 8 x squared plus 4 raised 7. Are we done yet?
No.
No. I'm done. So u v prime plus v u prime. U v prime plus v u prime. Okay, algebra. What's common between this term and that term? Just two.
X squared. X squared
A lot of things.
What are the lots of things?
X squared plus 2, x squared plus 4. And then,
So between this term and that term, I have x squared plus 2 cubed in common. Yes. Between that term and that term, I have x squared plus 4 raised 7 in common.
Yeah.
8 times x, and I have 8x. So 8x is in common. What do I leave behind? So here, I'm leaving behind x squared plus 2 times 2x.
it's plus 2.
So sorry,
Yeah,
plus 2.
2x. How'd you get the 8 at?
Yeah.
Multiply
So 8 here,
Yeah.
4 times 2, 8.
Oh.
So 8x is in common. That x shouldn't be there. So I took the 8x out. I took x squared plus 2 cubed out. I took x squared plus 4 raised 7 out, which means I'm left with x squared plus 4. Good.
The next one.
Not done yet. So 2x squared plus x squared, 3x squared. So 2x squared plus x squared, 3x squared. 2 times 2, 4, 4 plus 4, 8. What I'm going to do, I'll call this as y. I'm going to take logarithm on both sides. So ln of y would be equal to ln of that entire term. Yes. I just took ln on both sides. From last week, I mentioned anytime you have logarithms, what is the first thing that you should do?
Isn't it the multiply together, you do one over the other?
Can't you add them?
Yeah.
Because they're multiplied.
Use the properties of logarithm. A times B yes, plus should we proceed with taking the derivative, or is there something else that we can't do before moving?
Or something.
Move the 4 to the front. And now moving the 8 to the front. Can I erase this side?
Yes.
Now I'm going to take the derivative on both sides. On the left hand side, what is the derivative of ln of y?
1 over y.
1 over y times y prime. Good. Now, right hand side, 4. What is the derivative of ln of x squared plus 2? 1 over x squared plus 2. Is that it? Times 2x. Yes. Multiply or add. What is the derivative of ln of x squared plus 4?
8 times 1 over.
X squared plus 4. Are we done? No. Multiply by 2x. What do I see in common between the two terms?
2x.
So 2x is in common, 4 is in common, right? So all in all, I have 8 in common and x.
2x is in the
4 times 2, 8.
Oh,
8 times x. And that would leave us with 2 over x squared plus 2.
wait, no, that's.
You did one
That's
plus two.
16.
That'd be 8 times
That's
2,
16.
16.
Yeah, 8 times.
Yeah.
Okay.
You just did 4 times.
I pulled the 8
Then you
out.
just take the egg.
You didn't multiply by 2.
Yeah, no,
Oh,
pulled it out, it's
okay,
4 times
okay.
2, not 8 times 2.
So how do I combine those two? Common denominator. What is the common denominator?
Both of them combined.
Both of them combined. Multiply and divide by the opposing denominator or the other denominator. Good. So I have a common denominator, so I can combine the numerators. Left hand side, 1 over y times y prime equals 8x. The common denominator, which is x squared plus 2 times x squared plus 4. What is in the numerator when I combine x squared plus 2x squared, 3x squared, 4 plus 2 times 2, 4. So 4 plus 4, 8. Good. We're almost there. Should you stop at that step? No. We want to find the derivative of y. So how do we do that? multiply that y to the other side. Correct. Should you leave it there? Sorry, sis, no.
Wouldn't you just move the y to the front? Could you do that? Like, would it be like that on the, on the test?
Sure, I can move the y to the front, that's okay. There is something else that I
I
can
know. Multiply like terms, so like make y part of the equation.
It's the original function.
take the original function, which is y, and throw it back in there. What is the original function? That. Yes. Just replacing y by whatever that's given in the problem. That will get cancelled. That will get cancelled. So the answer 8x times 3x squared plus 8 times x squared plus 2 cubed times x squared plus 4 raised to 7. Is this answer the same as that one? From method 1, they are one and the same. So here we've got multiple times in product. Very high powers where you cannot form, or you have a power which is a function of x. All of those cases require natural logarithms or logarithmic differentiation. So multiple times function in the power of an expression, exponentials, all cases. So yes, so root x is the function, and I have function. The power is also a function, it's not a constant. Do you agree? So this is a case where you have a function in the exponent of another function. So the very first thing to do is to take ln on both sides. When you do that, what would happen to the x? It moves in front of ln. Moves to the front. Should we proceed with finding the derivative right away? Or is there something else that I can do before moving on?
Change the root.
Chain rule, sure.
Convert the square root to 1/2. X raised to
I can rewrite this as x raised to 1/2. Yes. Move the 1/2 to the front. Add that.
So you would be able to do that even if it's in the parentheses?
What do you mean?
Like,
Yeah. As long as it is a term by itself raised to a power, you can move the power up. It has to be a term by itself. Well, given the option between that and that, which is easier to differentiate? This. So take the derivative on both sides. What is the derivative on the left-hand side?
y over 1/2.
1 over y. Are we done?
No.
Y prime. What should we do on the right-hand side to find the derivative?
You move out the x squared and then you take the derivative.
Move up to x squared.
Like the x, I mean, x over two, you like move it to the side and then you take the derivative.
Why would you move that to the
It's not like
side?
moving to the side, but you know, you take the derivative of ln of x, right?
It's like 1/2
Productful,
x.
so you,
Oh, no way.
wait. Yes. You. What is the derivative of ln of x? 1/x. So u, v prime, plus v. Derivative of x over 2. X. What is the derivative of x over 2? X over 2 is the same as 1/2 times x.
1/2.
1/2, okay. So times 1/2. Good. X's will get cancelled. What do I have in common between the two terms? 1/2. If I take 1/2 out, I would have 1 in the first term, ln of x in the second. Good. On the left hand side is 1 over y times y raised, excuse me, y prime. Are we done yet? No. What should we do? Multiply by y. Here is a hint. Anytime we use logarithmic differentiation, it's a 99% chance that you would be able to rewrite the derivative in terms of x, always. Because you initiated the substitution at the beginning, which means you can plug it back in at the very end. So what is y? Y is square root of x. Square root of x, raise x, divided by 2, multiplied by 1 plus ln of x.